All right, scholars. So let's do this final review um, before your state test. I just want to let y'all know I'm really proud of y'all. I'm really proud of the work that you've done this whole year. So I honestly think that you're gonna knock this out the park. But just one last crack at just like feeling confident, right? And understanding some problems that you may not have had much practice on. Okay. So we're gonna look at a few things. We're gonna look at MAD, which is mean absolute deviation, interquartile range, and like how to build a box plot. So step one, when we are going to calculate the mean absolute deviation. The good thing about mean absolute deviation, I think the um, learning and understanding how to solve this is in itself, right? You have mean, which is the average, absolute, which means like distance is always going to be positive, and deviation, right? You could just say like from mean. Now, if you're so confused about that, as we work through that, you'll start to see how the MAD or mean absolute deviation follows all of this. So here's a data set. We have a data set here, and the first thing we need to do is find the mean. To find the mean, you want to add all of the data, all of the numbers, and divide by the amount in the data set. So mean, add numbers, and divide by numbers and data set. So we got to add these up. Most likely you will have a calculator for this. So one thing I want to stamp is that, yeah, you want to, when you have a problem that's calculator active, you want to just write down the formula or the steps to solve it, but you don't got to do the thinking. Let the calculator do the thinking because you don't have that much time. 12 plus 15 plus 18 plus 20 plus 22 plus 25 plus 28. And I know I could double check 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and divide that by 7. Now, the thing about the calculator is that you want to add it up, but you want to make sure you look at it twice because you can make a silly mistake on the calculator. 12 plus 15 plus 18 plus 20 plus 22 plus 25 plus 28. 140 divided by 7 equals 20. Then you want to do it again. 12 plus 15 plus 18 plus 20 plus 22 plus 25 plus 28. 140 divided by 7 is 20. So the mean is 20. So we found the mean. We did that. We found the mean part, right? Now find the absolute deviations, which means like how far is each point from the mean. So then you want to list all your numbers again. Your mean is 20, so you want to put 20 here, and you want to box it. Now you want to list all the numbers before the 20 and after the 20. So 12, 15, 18. And since 20 is a part of the data set, you want to also put that underneath there. Then you have 22, 25, and 28. Now, the absolute deviation means from 18 to 20 is 2, but since you're going backwards 2, a lot of people think that that is a negative. But since it's absolute, it's always a positive. Okay. So, and it's always going to the mean. From 18 to 20 is a positive 2, and everything from 15 to 20, positive 5. From 12 to 20, positive 8. From 20 to 20 is a 0. This is the part I need y'all to really understand. If the mean is the same as what it needs to be deviated from, since it's a part of the data set, it has to be included. From 22 to 20 is a 2. 25 is a 5. 28 is an 8. Right? So now you have to find the mean of the deviations, of the absolute deviation. So from 12 to 20 was an 8, plus 5, plus 2, plus 0, plus 2, plus 5, plus 8. And then you want to divide that by 7. So let's calculate it again. 8 plus 5 is 12. 12 plus 2 is 14. 14 plus 2 is 16. 16 plus 5, 21. 21 plus 8, 29. Double check that. I believe that's right. 8 plus 5 plus 2 plus 2 plus 5 plus 8. 8 plus 5 plus 2 plus 2 plus 30. Yep, it's 30. 30. And so you have to find that mean. So you have to divide 30 by 7. Which is 4.25, which is about 4.3. Yeah, estimated. So the mean absolute deviation is 4.3, which means that like on average, each number is about 4.3 away from the mean. Step 2, calculate the interquartile range. So we just did the mean absolute deviation, and now we're talking about the interquartile range. Now, when we're talking about interquartile ranges and box plots, the really big thing to understand is median is important in here. In the mean absolute deviation, it was mean, and the interquartile range is median. So first you have to arrange the data from least to greatest. Since it's already in order, that's great. Then you want to find the median or the middle value of the data. Here's a quick note. If data set is odd, there is one middle number. However, if the data set is even, there is two numbers in the middle, and you have to find the average of two numbers. Okay. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Since it's 7, then you know that there's only going to be one middle number. So you want to make sure it's listed from least to greatest. You have 12, 15, 18, 20, 22, 25, 28. Cross out each one at a time and put a line through it. So the median is 12. Or the median is 20, excuse me. Now, in order to find quartile 1, now, Mr. Ray, what's quartile 1 and all those things? Well, when you're dealing with the inner quartile range, inner quartile is what you need to understand. So you need to have the minimum, quartile 1, quartile 2, which is the median, quartile 3, and maximum. The inner quartile range is from quartile 1 to quartile 3. However, the entire range is from the median minimum to the maximum. Okay, so to find quartile 1, so we're going to find quartile 1 and quartile 3 with all this information, right? So we have 12, we have 15, we have 18, we have 20, which is our median. We have 22, we have 25, and we have 28. The difference between mean absolute deviation and inner quartile range is if the median is given, then you do not count it, right? So do not count. Basically, do not recount. So now we have to find the median of the lower half. So cross that out, cross that out. So the median of the lower half is 15, and that is going to be quartile 1. Then you have to find the median of the upper half. Cross that out, cross that out. So 25, which is going to be quartile 2. Now, the inner quartile range is the range or the difference of quartile 3 minus quartile 1. And in here, we know quartile 3 is 25, and quartile 1 is 15. So the inner quartile range is 10. And the difference is the range is from 12 to 28, which is different, but the inner quartile range is from the quartile 1 to quartile 3. Another good note to understand is quartiles mean quarters, right? So from each of these data points to the next, it represents 25% of the data, which means the inner quartile range represents 50% of the data. Or 1/2 of data. Okay. The quartile range is 10. Move on. So finding the inner quartile range is really cool, but what makes it even more cool is the understanding that, like, if you know how to find the inner quartile range, then you can easily build a box plot. Sometimes you have to find the median, find the quartile 1, but sometimes it's given to you, right? So like reading the problem and seeing what all of those things are. So using this, we're going to use these steps to solve. So since we already have this, we don't need to create this. But it's really good to understand what your minimum and maximum is, which helps you figure out what is your range when creating your box plot. So because the minimum is 12 and the maximum is 28, your numbers, you want to range your numbers so that like it don't start with your minimum and maximum, but it's a range of numbers so that when you create your box plot, it's centered within a set of numbers. So draw a number line from 10 to 30. I could do that better, but there's there's my line. Then mark your 5 number summary. So my minimum is 12, so I want to mark that here. My quartile 1 is 15, so I want to mark that here. My median or quartile 2 is 20, so I want to mark that here. My quartile 3 is 25, so I want to mark that here. And my maximum is 28. So I did that, and I did that. Draw a box from quartile 1 to quartile 3. So quartile 1 to quartile 3. Draw a vertical line at the median. Draw whiskers from the minimum to quartile 1 and maximum to quartile 3. And so you have your minimum, quartile 1, quartile 2 or median, quartile 3, and maximum. See that? That is your box plot. And this represents 50% of the data. Okay. Now we want to do some practice, but I'm going to save that for the next video.